This is an overview of the contact tracing device manufacturing test and assembly process. There are three primary areas. First, we start with the plastic injection molding, which is used for 4 parts. The top and bottom housing, grey strip and LED light pipe. The injection molding machine heats up raw plastic pallets and injects them into a stainless steel mold. After a short weld time, which cools the heated plastic, finished part is either moved by hand or via machine as shown here on the conveyor belt. Here is a view of the mold as it separates, as well as images of the LED light pipe and housing tool. Finally, we can see an operator removing the strip from the injection mold and a view of the finished housing. The second area is a surface mount technology or SMT process. This is used to produce the printed circuit board assembly or PCBA. Starting with the raw printed circuit board, a machine adds solder on the key location to hold and electrically connect the various electrical components. There are then 2 pick-and-place machines which first place the small electrical components like capacitors and resistors on the board, and then another pick-and-place machine for the larger electrical components such as the RF module and memory chips. A visual inspection tool confirms the proper placement of each component. Once confirmed, the now populated board is placed in an oven which cures the solder and completes the PCBA process. The final and third area is the assembly test and packaging of the contact tracing device. After PCBA level functional testing, we begin with the verified PCBA and add a custom cut piece of copper over key components of the board to eliminate sources of noise which impact the RF signals received by the antenna and from other devices, personal beacons or phones running the app. Next, we install the battery by connecting the battery lead to a connector on the PCBA. A rubber cap is then installed on the housing to prevent water from entering the reset hole. The device label is added via a laser edging process. The cam reads the label on the PCBA and then translates that into a unique device and QR code. A laser then edges the bottom housing plastic, creating the label. There are features in the bottom housing which are used to properly locate and hold the battery and PCBA in place. The top housing is then seated and the full unit is placed in an ultrasonic welding machine. This machine uses high-speed vibrations and pressure to heat up the plastic along the housing seam and weld the 2 plastic pieces together. The assembled devices are then placed in an RF isolation chamber where a number of tests are run, verifying the end-to-end functionality of the device. All test logs are stored for future reference and production yield monitoring. Now verified, the strip is snapped on the front of the device. The devices are next charged as needed to a full battery state. They are then turned off and considered functionally ready to go. The belt clip is then screwed on to the bottom housing using an automatic torque wrench. All components are then placed into the device box, including the USB charging cable, the lanyard, and the FCC insert. Before being added, the device QR code is scanned, which creates a sticker for the box with a matching device ID and barcode. Finally, the packed devices are scanned and added into a shipping carton. This carton holds 50 devices and has a unique identifier that references which devices are included. The next stop is shipping to awaiting clients and customers.